How are you, students? Yeah, once again, I just stand in front of you to handle with one important topic, nothing but sign convention. Before that, welcome to Bhaskar Physics. Please subscribe, like, share. Right? Okay, sign convention. Right? You know, when we are handling or dealing with the reflection with a spherical mirror, reflection at a spherical mirror. When we are dealing with the reflection at spherical mirror, right? The sign conventions are very important. Okay, nothing but this sign convention. Also, it is also called as a what is this? Is a new Cartesian sign convention. I am writing here new Cartesian sign conventions, right? So it is a very important, and also a mathematical calculation purpose also we have to apply this sign convention, right? Now I am talking about the sign convention for the spherical mirrors, right? Okay, we will discuss in the case of the lens also this concept. Right now I am discussing about sign convention for in case of the spherical mirror, right? Okay, fine. Now here you can take it now here. Just I am taking here only concave mirror, right? What I am speaking about a concave mirror, you can apply these rules to the convex mirror also. Okay. Now here you can take a concave mirror. This is a concave mirror, right? I am drawing. This is the concave mirror. Okay, right. So here this is the principal axis. Okay, this is the principal axis. Okay, right. Now here you can observe what is this is this point we can call it is a pole. P stands for pole, and here F stands for the focus. Here C stands for the center of curvature. Repeating once again. What is this line is called? Yes, this line is called the principal axis. What is this mirror is called? Yes, APB is the concave mirror. What is the P is called? P is called a pole. F is called the focus. C is called the center of curvature. Right. Here, what is the distance from pole to focus here? Right. The distance between pole to focus we can call this is the focal length. Remember, this is already we have discussed in the previous classes, right? And what is the distance from center of pole to center of curvature? Right. The distance from pole to center of curvature we are calling it is a what is this is a radius of curvature. I am writing the terms. P stands for pole. Okay. F stands for focus. Right. C stands for center of curvature. C stands for center of curvature. F stands for focal length. Okay, and the last one is a R stands for radius of curvature. What is this is radius of curvature. Okay, this is the terms. Okay, immediately we have to know that. And we have to remember these terms. What is P stands for pole, F stands for focus, C stands for center of curvature, F stands for focal length, R stands for radius of curvature. You know, most of the students will do mistake here. Damn sure here look at. Some of the students focal length they are mentioning with a capital F. You should not mention, that is a mistake. And also focus you have to mention with only capital F. This is a mandatory. You have to remember these two symbols. Focus for the capital F. This is for F is for the focal length. Sometimes this focus also called as a focal point. It is also we can write. It's not a problem in some of the textbook. It may be mentioned F is equal to focus or focal point. So both are same only. Right. This is about points. What we have to memorize. Right. Okay. This is not our topic. No. Why we have to drag this much? Right, I think it's not needed, but it's needed, right? Okay, right. So very important point, that is the first one here, the first point, right? We have to measure all the distance from pole only, right? You have to measure all the distances must you have to measure from pole. From where you have to measure? Right, I am using for you a other pen also, blue pen, right? Okay, fine. This is the mandatory. You have to measure from pole, right? So where is the pole? This is, right? So look at pole to focus, not from focus to pole. Don't go. You have to come from pole to focus, nothing but focal length. Pole to center of curvature. This is called radius of curvature. You have to measure all the distance from where pole you have to measure. That is the first important point, right? And next one here, look at here, right? So not only it is clearly, right? Now here you can observe here, right? For example, okay, you can keep one object here. This is the position of the object. AB is the object, right? This is the direction of incident ray. I am writing it is this is the direction of incident ray. Okay, direction of incident ray. You can remember very clearly. Direction of incident ray, you can take it as always positive. Then you will not get confusion. Direction of incident you have to take always positive. Then you will not get a confusion, right? So if the ray is moving in this direction, what you have to take? Incident ray. If for example this is the my black pen, it is incident ray, it is moving in this direction. If anything else, if object distance, if you are moving towards the direction of incident ray, you can take plus. If you are moving opposite direction of the incident ray, what you have to take? You have to take the negative. Very clear. If you are moving towards opposite to the incident ray, okay, you have to take always negative. Okay na? Right, because incident ray direction you have taken positive, then always if you are moving opposite to the direction of incident ray, you have to take to the negative, right? Okay, and next one here, one more point here, just wait. The second point what I said here, right? Here second point, it is incident ray direction of the incident ray. Okay, you have to take the direction of incident ray, you have to take positive. Okay, right? If you are moving, if you are measuring values, if you are measuring opposite to incident ray, okay, you have to take minus. Very clear, right? If you are taking incident ray direction, you have to take the positive sign, right? Okay, and if you are taking, right, measuring opposite to the incident ray, opposite, remember this word, opposite to incident ray, you have to take negative, right? Okay, this is about the second point. Must and should you have to remember this condition, right? And next one here, second condition is completed. Okay, right. What is the third condition, right? Okay, very clear it is. For example, object, this is the object. If object is on the principal axis or perpendicular to the principal axis, if the object or image, if you take a object or image perpendicular to, okay, perpendicular to principal axis, you have to consider as positive. Okay, this is one, object or image on the principal axis, you have to take what it is a positive. If the object or image on the below the principal axis, okay, what is the below the principal axis? Okay, below the principal axis, you have to take negative. Okay, right? If the object is on the principal axis, you have to use the positive sign convention. If the object is or image is below the principal axis, you have to apply the sign convention for negative, right? So this is the three main important rules to calculate the what is the focal length value, to mention the sign convention, focal length value, okay, etc. Now we will show one example here, right? You know, look at here, very clear. This is the concave mirror. Look at focal length you can take, concave mirror focal length you can take. This is the incident direction. It is a positive I side. Now I have to measure the focal length. Pole to focal length. Which side I am moving? I am moving this direction. Pole to focus, right? So I am moving to the opposite to the incident ray direction. What is that opposite incident ray? Plus or minus? Yeah, you are right. Minus. So focal length here you have to take a negative, right? And next one here, if you want to calculate radius of curvature, pole to center of curvature, you are moving this side only, no? You are moving this side direction, which is opposite to the incident ray. Then radius of curvature you have to take to the negative. Do you understand? Right. Okay. You may get doubt. What about in case of a convex mirror? Yeah, I will show. This is the convex mirror, right? I am taking here convex mirror. This is the principal axis. Here is the pole, right? Where is the focus? This is the focus, and this is the center of curvature. What is the distance from pole to focus? F. Here this is the distance it is. And what is here distance from pole to center of curvature? Radius of curvature. What I said, this is the incident direction, no? Right. Now look at pole to focus. Which is the direction I am moving? I am moving towards the direction of incident ray. Am I correct or not? Towards the direction of incident ray. So here what is the focal length is equal to? Yes, you are right. It is a positive. Right? And here, if you are moving towards, again, radius of curvature, if you are calculate, you have to get from pole to center of curvature. You are moving towards the incident ray direction. So what is the radius of curvature? It is also positive. Very clear? Right. Very important values here. Focal length and radius of curvature in case of a concave mirror, we will get both negative. Remember this point. And when we are speaking about in case of a convex mirror, focal length and radius of curvature, we are getting the positive. Okay? If you are clear about the sign convention only, you can apply these rules, and also this sign convention is very helpful to derive the mirror formula as well to calculate the mathematical calculation also, right? So this is about the sign convention, right? So I am coming with the next video. It is another topic. It's a very important topic, right? Until that, take care. Bye bye.